Continuing on physical chemistry, chapter 10. This is section 1, the only section we're going to do in chapter 10. We're talking about activities and the activity coefficient. Now, we've been talking about ideal solutions. So we had mu of substance I in the ideal is equal to mu I naught plus RT times the natural log of the mole fraction I. That's for an ideal solution. Now, if we solve that for the mole fraction of x of I, we get x of I is equal to e to the chemical potential I in the ideal minus chemical potential I at the standard state divided by RT. And this is for an ideally dilute solution still. Now, we're going to define the activity A, this is subscript I. Well, this is activity A. So the A in subscript I is defined as E to the mu I minus mu I naught over RT. And this is for any solution. Notice we got rid of the ideal here. This is for a real solution. So, take the natural log of both sides. We get the natural log of the activity for substance I minus the chemical potential for substance I minus the chemical potential for substance I at standard state divided by RT. So, if we solve for the chemical potential of I, we get the chemical potential of I is equal to the chemical potential of I in the standard state plus RT times the natural log of the activity of substance I. And this is for a real solution. Now, if we combine the chemical potential of substance I is equal to the chemical potential of substance I in the standard state plus R times the absolute temperature times the natural log of the activity of A with what we have for ideal, which is the chemical potential of I in the ideal, is equal to chemical potential in the standard state plus the ideal gas constant times absolute temperature times the natural log of the mole fraction of substance I. What we're going to find out is that if x of I is equal to a sub I, so in other words, if the mole fraction of I is equal to the activity of I, then for an ideal or ideally dilute solution. Now, what that means is that if we have mu sub I is equal to mu sub I naught, then that's when we get a sub I is equal to a sub I naught, or that's equal to 1, which gives us that RT is times the natural log of A is equal to 0. Okay, we're in chapter 10, finishing up chapter 10 and section 1. This is all we're going to do for chapter 10. So the chemical potential for substance I is just mu sub I for a real solution, or mu sub I superscript ID for an ideal solution. Now, if we want to know the difference between ideal behavior and real behavior, we just subtract mu sub I minus mu sub I ID. And that's equal to RT natural log of activity minus RT natural log of mole fraction. Using the log rule, we can combine those into one fraction and get RT natural log of activity over mole fraction. Now, this ratio of activity divided by mole fraction, this is the departure from ideal behavior. Now, we're going to define a new symbol, gamma sub I, as equal to this ratio that we derived. So the activity divided by the mole fraction. So this symbol is gamma, and gamma sub I is called the activity coefficient. A sub I is going to be equal to gamma sub I times mole fraction of I. Now, if gamma sub I is equal to 1, then of course activity of I is just equal to the mole fraction of I. Now, by the way, of course, A sub I has to be greater than 0, and gamma has to be greater than 0. Now, for ideal or ideally dilute solution, then we have gamma sub I is equal to 1, and then in that case, the activity of I is equal to the mole fraction of I.